Welcome. So today we have a question that has been repeated twice on these two shifts. So the question reads, find the minimum angle of deviation for a prism of refractive index mu is equal to cot A by 2, where A represents the angle of the prism. Let's see the diagram. Okay, so here is a diagram where the ray enters and exits, and we have to find the angle of deviation. Okay, so as you can see, the total angle of deviation is given by delta 1 plus delta 2. These are the deviations from two interfaces, and we can clearly see these are I minus R1 and plus E minus R2. Now you can notice that since this angle AQN and ARN are both 90 degree, and AQNRA makes a quadrilateral, the two sides are 90, so rest of the two sides are also 90. So A plus angle QNR be 180, and we also know that R1 plus R2 and angle QNR are 180 degree. Now using these conditions, let's move on. What do we get? What we obtain is R1 plus R2 is equal to angle A, and our angle of deviation, the angle of deviation is given by I plus E minus R1 and R2, so we have the A. Now for the minimum angle of deviation, what do we need? The entrance and exit has to be symmetric, so I is equal to E. So for minimum angle of deviation, 2I minus A is the condition. Now from the next condition, what you get is R1 and R2 are equal to same value, that is R. So we'll get the angle of refraction R is related to angle of the prism. And finally what we can write, mu is equal to cot A by 2, and we have to write sine I by sine R. Now from this it is very clear the sine and sine terms are gone, so what we will get, we'll get cos A by 2 is sine A plus delta by 2. Now rewriting this, we can clearly see pi by 2 minus A by 2 is equal to A plus delta by 2. Now solving the angle of deviation is pi minus 2A. Thanks a lot for your attention.